liters per minute. But during exercise, it could go way up to about 17,500. That's several-fold. That's like a threefold increase, isn't it? Yeah.
Yeah.
Almost, yeah, threefold increase, and that's because the heart can actually be stimulated to beat a lot more. But let's look at some of these real quick. If you notice here that the brain's blood flow is maintained at the same level, and that's because you just cannot jeopardize. The brain cells are so fragile that they have to have a constant flow, blood flow. You don't want to mess with the whole system up there in the brain. So therefore, the blood flow is maintained. However, the rate at which the cells take up oxygen, take up glucose, could be accelerated during exercise or during stress or when you're reading hard. I mean, like for instance, like me now, when I was preparing for this class, oh my goodness, I was hungry all the time because I was just using so much effort just to understand what I was reading in the first place and think about how to put it in a picture and draw it and make it understandable to the layperson. So that process takes a lot of energy. Blood flow pretty much remains the same, but energy is taken up more, especially when you're exerting using your brain. Of course, the heart, because it has to pump 3 times as much, you can see that it takes in a lot more, taking a lot more blood through the coronary vessels, and just goes further down. What I couldn't understand was that with the abdomen, I didn't understand why it had to be multiplied so many times. That's like I don't know, quite a lot. I need to read that some more, but I think that has to do with when you're exercising, you need a lot more energy, so maybe the blood vessels have to go to the intestines and take up more food and more particles to be digested by the muscles and the other parts of the body that are involved. Of course, skeletal muscle increases and all that. Okay. Any questions, Sherry?
Well, why does the distribution of blood go down in the kidneys?
Because, well, when it comes to exercise, you are trying to conserve. You're trying to minimize unnecessary places. You want to shunt the blood, shunt nutrients, shunt oxygen to the parts of the body that need them the most. The kidneys don't really need them. The kidneys are just there to remove excess waste and excess water. So they don't really need blood flow that much, but the muscles do, and of course the heart muscle does too.
Yes, this is great. This is fascinating.
Oh, okay. Thanks. Okay. Here's a slide messed up. This is heart, folks. I don't even know why I had to write heart in it. I mean, the picture speaks for itself. But I made a mistake. I should put a T there. I forgot to put a T there. And the whole idea I'm trying to portray here is that blood flow. The heart has to pump blood to the body cells. When there's ample blood flow for that organ or for that tissue, the cell is happy. It gives all the nutrients that it needs. And I had this picture up here to show that if there isn't ample blood flow, and here's the problem. Different parts of the body are not as well perfused as the others are. Now, let me give you this quick example. The face is extremely well perfused. You can see, and these are muscles actually, but this correlates. I mean, the muscles, the red parts, are also correlate with the amount of blood flow. So you have more blood flow around these areas, or blood perfusion around these areas, because they are red, and they basically, you can just, it usually is a good correlation. Let me just put it that way. The face heals. If you have a cut on the face, it heals a lot faster than, let's say, on the foot, on the back of the heel, for instance. The same thing with if you think about the back. Now, 20 million plus people a year in the United States are suffering from chronic back pain. And where does back pain, what's the commonest site for back pain?
The lower back, right where there's not much circulation.
Exactly. Lower back, right there. There isn't much circulation. So it doesn't really heal as well. Of course, part of it is that the lower back carries a lot more load. It carries most of the load of the weight of the body. But if it had more perfusion, it would probably heal better, and you wouldn't have all those problems. Now, who am I to challenge the way we were built and made? But that's what I noticed about this. So the key, again, is perfusion. Cells have to have adequate perfusion in order to be healthy. And what happens if you don't? if for any reason, either this blood vessel is cut, it's occluded, maybe it's like I mentioned, platelets. If there are too many platelets and they block the place, or if there's a thrombus, or even if there's a cancer cell, whatever it is, especially when it comes to the smaller blood vessels like the capillaries in the fingers, in the toes. As I'm saying this, I'm thinking about sickle cell disease. Black African Americans suffer a lot more. They have that disease, sickle cell disease. White people don't have that. White people have cystic fibrosis, so it's one or the other, both genetic conditions. In sickle cell disease, the problem with sickle cell disease is that the red blood cells are no longer as elastic and as smooth as they should be, and so they get easily hardened and they get easily damaged, and they easily could, especially when it comes to small capillaries, they could block the blood vessels. And when that happens, it could result in a couple of things. It could result in death. It could result in the release of chemicals which cause severe pain. And I saw these sickle cell kids. Oh my goodness! I mean, your heart just goes out to them. I know a kid who was like 25 years old. He was the height of a 6-year-old because he had so many what they call sickle cell crises, that his bones had broken down, his muscles had decayed, and he was just, your heart just went out to him, like I said. But all that is because of disruption in blood flow. This also applies in, hang on, let me just go back to that real quick. This also applies in, well, when it comes to cardiovascular disease, for instance, with stroke. When it comes to stroke, it's because the brain cell somehow has been cut off from its lifeblood, its blood supply. The blood, either the vessel got occluded, or like I said, it exploded. And when it comes to high blood pressure, the blood vessels are just exploded, and so the blood did not get to the brain cell, and that causes death. Anyway, there are lots of things we can talk about this. I got this from Dr. Harry's slides. One of the advantages to putting up shows like this is that you get to use everybody else's information. It makes you look smart. People think you're smart. All right.
Said you are.
Oh, well, thanks a lot. Thanks. Here you have, I don't know what you want, Sherry, but you're not getting it. Anyway, here you have the carotid arteries. The carotid arteries actually supply the brain. They're the most important vessels that actually supply the brain. And you can see the plaque building up there. And so, and we're going to explain a little bit more about what causes plaque. Inflammation plays a part. Yes, cholesterol plays a part, but it is not as obvious as the establishment wants us to believe. And here's what happens when you have atherosclerosis. That's when cholesterol, plaque, white blood cells, dead tissue begin to build up in what should be a normal arterial lumen, a normal space. Okay. Are we okay?
Yes, I have a question. Is it more likely that you would have that narrowing in those places in your body where there's not as much flow? Or is there not really a connection there?
That's a good question. Is it more likely? It could be. What we know is that there is a generalized, when you have inflammation and when there's plaque buildup, it's usually all over the body. It's usually in all the blood vessels. Now, if you have a white lumen, then there might be buildup there, but because you have such a white lumen or bore, the blood still flows through, but it shows up more if the lumen is narrow, like you mentioned. So it's more likely that you're going to see the effects when the lumen is narrow. Make sense?
Yes, thank you.
Okay. And again, here's some more pictures. Here's part of what causes the disease. If there's a cut, now this is, again, you're looking at the cross-section of a blood vessel, okay? So this is the outer shell, the outer covering, and this is the inner lining. So in here would be the red blood cells. If there's a cut here, damage from anything, I mean, we constantly experience damage in our blood vessels, but because we're healthy, hopefully, the body is able to heal it and detect it in time and plug up the hole. In some cases, if there's a problem with inflammation in the body, and again, we're going to get to that, it causes the buildup of blood clots. But let me move on to the next one. I show this picture here because this is probably the key thing when it comes to stroke. It's a cessation in some part of the brain due to a couple of things like we mentioned. In Alzheimer's disease, let's say, for instance, with the brain, what they're finding out is that